All right, welcome everyone. Today we're going to go ahead and dive into the world of Python and Pytest. Yesterday we finished talking about JavaScript. Today we're going to see a lot of similarities between Python and JavaScript, but we're going to make sure that we cover the differences and the capabilities and limitations between each one as we move through each one of those independent data structures. With that said, a lot of the information that's going to be covered today may be recap. So in that case, we'll quickly cover over it and try to move into the interesting stuff. Sooner rather than later. So, before we start our lecture, let's go ahead and take a look at a quick, informative 100 seconds of Python here.
A high-level interpreted programming language famous for its Zen-like code. It's arguably the most
I just realized you guys probably can't hear that. Give me a second.
popular language in the world because it's easy to learn, yet practical for serious projects. In fact, you're watching this YouTube video in a Python web application right now. It was created by Guido van Rossum and released in 1991, who named it after Monty Python's Flying Circus, which is why you'll sometimes find spam and eggs instead of foo and bar in code samples. It's commonly used to build server-side applications like web apps with the Django framework, and is the language of choice for big data analysis and machine learning. Many students choose Python to start learning to code because of its emphasis on readability as outlined by the Zen of Python. Beautiful is better than ugly, while explicit is better than implicit. Python is very simple, but avoids the temptation to sprinkle in magic that causes ambiguity. Its code is often organized into notebooks where individual cells can be executed, then documented in the same place. We're currently at version 3 of the language, and you can get started by creating a file that ends in .py or .ipynb to create an interactive notebook. Create a variable by setting a name equal to a value. It's strongly typed, which means values won't change in unexpected ways, but dynamic, so type annotations are not required. The syntax is highly efficient, allowing you to declare multiple variables on a single line and define tuples, lists, and dictionaries with a literal syntax. Semicolons are not required, and if you use them, an experienced Pythonista will say that your code is not Pythonic. Instead of semicolons, Python uses indentation to terminate or determine the scope of a line of code. Define a function with the def keyword, then indent the next line, usually by 4 spaces, to define the function body. We might then add a for loop to it and indent that by another 4 spaces. This eliminates the need for curly braces and semicolons found in many other languages. Python is a multi-paradigm language. We can apply functional programming patterns with things like anonymous functions using Lambda. It also uses objects as an abstraction for data, allowing you to implement object-oriented patterns with things like classes and inheritance. It also has a huge ecosystem of third-party libraries, such as deep learning frameworks like TensorFlow, and wrappers for many high-performance low-level packages like Open Computer Vision, which are most often installed with the pip package manager. This has been the Python programming language in 100 seconds. Hit the like button if you want to see more short videos like this. Thanks for watching, and I will see you in the next one.
All right, perfect. So that's a quick informative video about Python. Now let's go ahead and continue moving forward into our actual lecture of what is Python and how it works. So the very first thing we're going to be covering is creating variables. Now, for variables here, go ahead and open up my main.py. For variables specifically in Python, whenever we go ahead and establish a variable, we're going to utilize snake casing. So for example, if I wanted to do something like my name, we'll notice that in JavaScript yesterday, we did something along the lines of my name. This is called camel casing. Well, in Python, you utilize snake casing, where every word is separated by an underscore, falling as snake casing. That's just a regular convention within Python. Again, just like in JavaScript, if I were to write a variable called my name and set it equal to a string of my actual name here, you'll notice that it doesn't throw an error. It's not going to necessarily do any sort of stoppage to make sure that you don't create a variable utilizing camel casing, but it is standard Python practice that when you go ahead and create a variable, you will always do it with snake casing. Now, another key difference, you'll notice that in JavaScript, I had to utilize something like let or const to be able to establish a variable. Now, that allows me a little bit of control in JavaScript as far as ensuring that const variables will become immutable. Meaning you cannot reassign a value to a variable. Well, in Python, we don't have any of that. In Python, whenever you establish or you create an actual variable, the only thing that defines the variable setting is the fact that we utilize an equal sign afterwards. So by calling the assignment character of the equal sign to the right of a variable, we create and assign a variable. Now, as we go through our primitive data structures here, you'll notice that we have strings, numbers, floats, and booleans. What else do we have in JavaScript other than these four, than strings, numbers, and booleans?
Null, undefined.
Yeah, we have null and undefined. That's because in JavaScript, we actually have the capability to do something like that. We have the capability to have something like null or create a variable that isn't actually defined, something that isn't assigned to something. Now, the equivalent in Python to null will be none. Right? So there's an equivalency there. But variables will still have to be explicitly assigned the value of none. In Python, there's no such thing as undefined. If anything within your Python script comes up as undefined, the Python script will automatically recognize that as a programming error and throw an error, letting you know, hey, there is nothing here. If you expected a value, then we have a problem because you're calling this information and there's nothing in there for me to work with. So we'll just strictly tell you there's no such thing as undefined, throw an error, which I personally like because the amount of times that I have ran into an error due to undefined continuing to work within my script has been more than I can count, and it has caused a lot of headaches throughout my programming ventures. All right, that is it for creating variables. Does anyone have any questions regarding variables? Perfect. If no one has any questions regarding variables, then let's move on into strings. Now, for strings, strings are actually very similar to Python. I mean, to JavaScript. Very similar to JavaScript in the fact that both strings in Python and JavaScript are immutable. We can still interact with them just like we did yesterday. We can access each independent index inside of strings, but we cannot just slice the string and expect the memory that's currently being allocated for that string to change. We can utilize variable reassignment, but we can't mutate the original value of the string. Now, when it comes to syntactical differences, there is a couple. So for the original example that we see for a string, my string, we could utilize double quotations to say, hello, this is me. We could utilize single quotations to state the same thing. And just like before, if I wanted to utilize an apostrophe at any point within my code, I would receive an error. In order to escape that secondary quotation, I would utilize a backslash, just like in JavaScript. Up to this point, nothing has changed. But what about something like interpolated string? If I have interpolated string, well, in JavaScript, I have to utilize backticks, and I have to utilize a specific set of characters to be able to set this information. Well, here in Python, you can still utilize double or single quotation marks. The difference is that you have to add an F at the beginning of the string. By appending the F at the beginning of the string, that tells the string that there may be some Pythonic code nested within it that needs to be interpreted or evaluated before the string can actually receive a value. So in this example, if I wanted to write some Pythonic code, I can say my age is, and in curly brackets, notice there's no money sign there at the beginning. In curly brackets, I can just say that my age is 10 plus 17. That would evaluate the code and assign my age is 27 to interpolated string. Let's take a look at this different string patterns here shortly. Let's go ahead and print. We're going to do my string. Let's do my string single. And then finally, let's print the interpolated string. To execute this code, I'm actually just going to type in Python into my terminal and call main.py. And by doing so, we can see that in the terminal, we get, hello, this is me, just as expected for my double quotation marks. We have, hello, this is me, and then the isn't, which is the example here of escaping the character. And then finally, we get my age is 27, which is our interpolated string, otherwise known as an F string, where we placed Pythonic code within the body of the string that was evaluated before being assigned a value within the string itself. All right. Does anyone have any questions regarding strings up to this point? Perfect. There's one last portion of string that I would like to cover, and this is going to be a formatted string. Now, a formatted string can be identified by 3 quotation marks. Now, typically you would have to do some sort of indentation, or you would have to annotate that you want to start a new letter or a new line by doing something like \n. And that series of special characters would start a new line saying, hello, this is a new line. If I go and print my string single, you can see that a new line had been started. And we get, hello, this is a new line right under it. Well, formatted strings work differently. We don't need that backtick n to be able to start new lines. We can actually specify line 1 and apply indentation. And it would read the blank spaces and also demonstrate them in the output of our string. There we can see the output of our string. We have a very empty line at the beginning. That is happening because there is nothing after the beginning of those 3 quotations. So empty. Now we see empty on that very first line. And then there's an empty line at the very bottom. That's because in line 23, the end is currently not showing any sort of input. That is it for formatted strings. All right. Another reason why you'll see formatted strings as you're working within Python or you're looking at documentation, a lot of the times code or comments are not written in actual comments. They're written within this formatted string template. This way, if anything's important or something's utilized to describe a function, they can be highlighted and annotated within the function. And it's not occupying any sort of extra memory or anything like that. It's just there so that other Python developers can also read it. All right, Dallas, let me hear the question.
It's called formatted string. So I was wondering if it has any other function besides what you've just shown here, or it just formats it based on where you have it on the lines. Does it do anything besides the \n effect?
The \n effect, and then also the tabbing function.
Keeps track of that. Okay.
Yeah, it's also showing us the white space. Other than that, it's really not doing anything more for us. It's under the hood. What it's doing is it's accounting. So although all of this is white space, it's analyzes characters within the formatted string. So all of this is still being assigned a value.
So it still has a much higher character count, even though on the terminal, when you don't highlight it, we don't see anything different.
Exactly.
Okay.
All right. Any other questions? Perfect. So now we're good with strings up to this point. Let me go ahead and comment that out. And let's move forward into speaking about integers. Otherwise referenced to or referenced to in JavaScript as numbers. Now there is a key difference here. Integers are only used to reference whole numbers of both negative and positive values. In JavaScript, we were able to also work with decimal points. Well, here in Python, that is not going to be the case. So I can call this my integer. We can see that the number 10 would be an integer. Just like in Python, just like in JavaScript, we have mathematical operators that we can take a look at here. And let me share this link with everybody so everyone has that available. Just shared that in the questions channel. So here we can take a look at Python numbers. Is it going to show me operators there? It is not. Let's see. There you go. But there is a couple of new, well, at least there's one more new difference or one more new capability that we have in Python that we didn't have inside of JavaScript. And that's going to be this double division sign. Stands for floor division. So for example, if I'm working within a number, we'll go ahead and do this here. And this number is an odd number, right? Let's say we have something like 15. And I am dividing by 7. Well, what would we expect that to return to the console?
15 divided by 7?
Yep. Put 14. All right, yeah, 15 divided by 7. That might be a
2 and
little
1/7.
bit, yeah, that might be a little bit out there, but we're expecting a decimal to come back, right? We see 2.14, and it continues back out into different decimal points there. What if that's not what I want? What if I just want to know how many times 7 can possibly go into 15? Well, we can utilize something like floor division. And what that's going to do is always round to the bottom whenever I'm gonna do my division. So now 15 floor division 7 would simply return 2 without having to return math and all of the other crazy stuff to be able to actually take a look at it. Now, additionally, in Python, or excuse me, in JavaScript, we also have the ability to increment or decrement by 1 by default. Increment or decrement by 1, utilizing either minus minus or utilizing plus plus. This would also reassign the value to the original variable. Well, in Python, we don't have that capability. And if we wanted to mimic something of the sort, we would actually have to utilize plus equals. Python does not have this capability. Instead, it's able to conduct an operation and automatically and reassign a variable to the new return value. Let's take a look at that. I have my number, and I make that equal to 10. What I can do is say my number plus or equals 5. And when I go to print my number, you'll notice that in the terminal, I'm going to go ahead and get 15. So what I'm doing here is I'm adding 5, and then I'm also reassigning it to my number. So if I were to take a look at this under the hood, what's actually happening is I'm saying my number is equal to my number, which currently the value there is 10, plus 5, which makes it equal to 15. That's all that's really happening in there. I can do this with other operators. So if currently right now I have 15, I can do my number division equals what it gets divided by 5, or excuse me, by 3, which would return 5. I could even do something like floor division 3 to make sure I can receive an integer. You'll notice a key difference there. When I did a regular division, it actually returns a decimal point. Whereas when I conduct floor division, it returns an integer. All right. Does anyone have any questions regarding mathematical operators or integers? Let's hear it, Carlos.
What's that, the greater than equals? I don't know if I missed that one, sorry.
X is greater than equals. Let's see here. I actually don't know that one. Let me go ahead and try it out here. I'm assuming this would return a Boolean variable.
Oh, I'm sorry. That one is a bitwise operation. It pushes the bit value of something to the right, if I remember correctly.
Oh, got it. Okay. Perfect. Yeah, I'm not familiar with that operation, and I wouldn't recommend utilizing something like that, or at least I wouldn't see the necessity for it up to now. Does that answer your question, Carlos?
Yes, sir.
All right, perfect. Now we've interacted with integers. Let's go ahead and start interacting with floats. Now, Floats are the Python representation I'll fix my spelling before I push it up to GitHub. I don't want to spend too much time concentrating on spelling. All right, so it's the Python representation of decimal points or decimal numbers. So if I want to do something like my decimal, I can make it equal to 1.5. And this is a floating integer or a floating number. If I go ahead and execute this, type my decimal, this will actually return the type. Here we can see we have a class of float. The moment that we see a point, that decimal number will automatically turn into a float. Now let's see what happens if we do my decimal plus 5. When you utilize my decimal plus 5, you can see that it's able to interact with them and actually utilize that decimal number. It turns 5 under the hood into 5.0 plus 1.5. So it converts that integer into a float in order to actually be able to complete this mathematical function. There's nothing too crazy in regards to floating number or floating integers. They're just simply marked or utilized to manage decimals. Once we start working within databases and we start working within Django, we'll talk about other different ways to manage decimals. But up to now, this is going to be the way we interact with floats. Any question regarding floating integers? Nice. No questions there. Let's continue moving forward and start talking about Booleans. Just like in JavaScript, Booleans are simply true or false. The only actual difference here is the way they are written. While in JavaScript, we have something like true. In Python, we have true. And just like that, we have false. In Python, we have false. The only difference is the capitalization at the beginning of the variable or at the beginning of the statement there. This keyword is true and false is just false. All right. Booleans are pretty straightforward. Gonna go ahead and we'll come back into Booleans once we start talking about truthy or falsy. And that's gonna happen when we're speaking about conditional rendering. That's gonna be it for our primitive types up to this point. Does anyone have any questions over anything that I've covered? All right, no questions. Something that I do recommend that we have talked about here is please go ahead and try to go into the strings portion of, or even all of your primitive types, and try to just interact with all of these different methods that are available for you. String manipulation is actually really important within Python, and you'll find yourself doing a lot of string manipulation regardless of where you are in your career. So the more familiar you are with the static methods with string, the better you're going to be at your job or overall as a programmer. Perfect. Let's go ahead and start talking about some complex data types, starting off with lists. Which is going to be the equivalent of an array in JavaScript. So just like an array in JavaScript, it is a series of data, or excuse me, iterable data that can be iterated through by index from left to right and hold alternating data types, both primitive and complex, for each independent index. You can take a look at that example that we looked at yesterday. This is a pretty straightforward example that I actually really like seeing. It's just a simple cart for every index. So index 0, index 1, index 2, and index 3. This list is assigned an integer, a string, and more string. Nothing too crazy there. I'm going to go ahead and make my list. Just like before, I can start it with an assignment, which is my equal sign, and then my opening and closing brackets there. And then I could just put primitive types. Say, hey, we have a string, we have a number, and we can also have something like a Boolean. That would give me my list. And just like before, we can access different indexes of the list. You can see that my list at index 1 would return 234. Just like my list at index 0 would also return a string. Now, a main difference as far as accessing a list inside of Python in comparison to JavaScript is that in JavaScript, the number of index must be a positive number. In Python, it does not have to be a positive number. It can be iterated through from left to right or from right to left. And the way you iterate from right to left is by adding -1. So let me go ahead and add those indexes there. So we know this is 0. We know this is 1. And we also know that this is 2. This can also be referenced to as -2, or excuse me, -3, -2, and -1. Here's my iteration from left to right. And here's my iteration from right to left. So by passing in my list -1, I would return true into my terminal. All right, does anyone have any questions about lists? Let's take it a step further here. We can slice through a list, and for slicing through a list, we don't actually have to utilize the method of slicing, right? In JavaScript, there's an actual slice method that belongs to an array. Well, in Python, what we have is the ability to just call the indexes that I would like to utilize. So for example, if I wanted to only get my 0 and first index, I would pass in 0 and 2. When this code gets executed, I receive string and 234. That's because the left-hand side of the colon is inclusive, meaning it's included in the generated output. And the right side of the colon is exclusive, meaning it will not be included in the output. Right? Index 2 is true. That's exclusive, meaning it is not included in the output. Now this 0, I don't necessarily need to add it. I can actually remove it. And by just passing :2, it's going to assume that the value on the left-hand side will be 0. Same thing vice versa. If I were to pass in 1 and colon, it would assume that the value on the right-hand side is the remaining of the list. So I would receive 234 and true. There's a lot of other array methods, or excuse me, a lot of other list methods that you can interact with. Here's our Python list. There's a small section to actually take a look at loops here. But here are all of the list methods that you can utilize to interact with list altogether. All right. At this point, does anyone have any questions regarding lists?
Yes, for the last bit that you showed for the slicing, does it work as start and stop, even if it's going from the opposite direction, from the end towards the beginning? -1 through -3 separated by a colon.
Yeah, it's a great question. Let's go ahead and try it out with -2, right? If we try it out with -2, you'll see that it still works and returns the output of 234 to true. Does that make sense?
And if you did -1 colon -3, what would you get?
That
Are
would
you trying to
wrong
reverse
order.
it?
Yeah, that would cause an error. So if I were to utilize -1, right? -1 is on the right-hand side to -3. Well, now I'm telling it to essentially flip the values upside down. So I would expect it to, so say it gives me an empty list. I would actually expect it to throw an error, right? But
It-
it's giving me an empty list because there's nothing that it can iterate through at that point. What I'm passing into it, it's not possible for it to go -1, and then it starts looking to the right-hand side, but there's nothing there,
Oh, okay. So you
right?
need another
if you put
colon -1.
if you put a colon after 3 and then a -1, what happens?
Going after 3 and then a -1.
And
Yeah,
that's the order of it.
I think
That's
that'll tell it to do
established.
it backwards. I think.
Oh, you mean flip it? Yeah, that would
No,
that would work.
Well,
no, no,
I
no,
want
no,
to see
no.
that too. If you can print that out for me, which is string 234.
Nick, are you talking like a flag at the end
Oh,
of
I see.
that that
Yeah.
has -1 to make it cycle backwards?
Oh,
Yeah, if you give it a third
I don't know.
argument,
Yeah.
-1, I think it does everything backwards.
colon -1.
What we're speaking
For
about
example.
here, this is actually flipping the string backwards,
Okay.
right? So this is reversing the string. And what it's actually doing here, it's not just reversing the string. What we're doing is slicing, right? We're slicing from the very beginning to the very end. That's the entire loop or the entire or list, excuse me. And then this is defining the direction. By defining the direction of -1, we're saying, I want the direction of this new list that we're generating to work backwards. So I believe the question was from -1 to -3, and then -1, then we would get true and 234.
Okay, that's exactly what I wanted.
All right. So I'll leave that portion there because that part is honestly a bit important. I have seen people struggle to reverse before. So let me go ahead and add that in there. Versus a list. All right. Perfect. Any other questions regarding list? All right. If there aren't questions regarding lists, then let's start looking at tuples. All right. Moving into tuples. Now, tuples work exactly like lists when it comes to storing initial data and accessing data within the list. The only difference is that once, or the biggest difference is that once a tuple is created, meaning with its initial data, it becomes immutable, meaning the data within the tuple can't be manipulated or changed. We can't add or append, pop, insert, or remove from a tuple. Once the tuple is created, that's it. Its original data is not going to change. Now, if a list comes in and I have the ability to append, clear, and actually do all of these functionalities and these methods to that list and change the original value of that data, and a tuple comes in without any of these capabilities, what does that tell me about a tuple and a list as far as memory space? Which one would occupy more memory space, a tuple or a list?
List.
A list, awesome. And a list is always going to occupy more memory space than a tuple because it has all this built-in functionality inside of it. So that's an important thing to keep in the back of your mind. If someone asks you ever in an interview of, hey, what's the difference between a list and a tuple? The first thing that you must annotate is a tuple is immutable, while a list is something that is mutable. And a tuple occupies less memory space than a list. Those are the two key things that you need to make sure that you're answering when somebody asks you the difference between a list and a tuple. All right. So now that we know that, let's go ahead and create our very first tuple. Something that wouldn't ever change are things that you would store within a tuple. For example, days of the week. We know that these will hopefully never change. So there we can see, we can start adding something like, hey, we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Now these values won't ever change, and I'm comfortable in saying that. So because I'm comfortable in saying that these values won't ever change, I can store them in an organized fashion inside of a tuple and expect this to execute every single time without a problem. I can still access information. So days of the week at index 0 would return S. I apologize, I never even went through the portion of explaining print. Print is the equivalent of console.log, except that we don't have a console. So print is strictly made to interact with the terminal. All right. So now we can go ahead and say Python main.py, and we would see S populate because at index 0, we have an S. At index 1, we would get M. And I believe you can also slice it. Let's go ahead and go all the way to index 3. And that would return S, M, and T. All broken down. And notice that even the data structure that comes back when I slice it is still a tuple. I am not changing the original data by slicing. I am simply returning a new tuple that only holds the values from 0 to index 2. All right, any questions regarding tuples?
What's the error you get if you try to
If I try to change or add something into it?
yeah, like assign it via index?
Yeah, let's do that. Let's go ahead and do days of the week. At index 1 is equal to Monday. And just try to switch it up a little bit. Well, when we run this, we get an error. Let's take a look at this error. It tells me specifically the file where this error is coming from. It gives me an absolute path to said file. It tells me, hey, inside of users, Francisco Avila on your desktop, there's Avengers notes, intro to JavaScript JS, intro to Python. There's a file named main.py. Okay, main.py, that's where I'm at. Then it tells me, hey, on line 77, here's my error. All right, this is where my error is originating from. It tells me days of the week, index 1 equals to Monday. And then it tells me specifically here, index 1 and the assignment. And it tells me type error, a tuple object does not support item assignment. It tells me, hey, you can't do this. You can't reassign a value for a tuple because tuples are immutable. Does that answer your question, Nick?
Yes, sir.
Perfect. Any other questions regarding tuples?
Yes, for that one, if you wanted to reassign it but still keep it a tuple, you would just on line 77 make days of the week equals, and that would just make it another, basically reassign the variable.
Yeah, you would have to reassign a new value to the variable. You wouldn't change the tuple. You could create a copy that would be similar to the tuple, but you would have to reassign to the variable, not actually change the value of the tuple.
Okay, so if I put days of the week equals, then days of the week brackets 1 equals Monday, then that wouldn't work because it's a tuple, so it can't be changed in any fashion, even if you reassign.
Yeah, so if I do equals days of the week index,
Right.
I don't even know how to do the syntax because this would be double reassignment. That would throw an error.
Okay.
That wouldn't allow me to do so. I would have to actually either utilize the spread operator, or I can actually look at some of the tuple methods here. Let's see. Tuple, so updating a tuple. There you go. So here you can see that the way it works is it actually turns it into a list first,
Oh,
and then afterwards changes a value and then returns it back into a tuple. So that's, I guess that's one way of.
okay. That's what I would have thought if I wanted to. I was trying to make it prettier, I guess.
Right. I'm actually surprised that that's the way they would go about it. I would have thought they would have unpacked it. There you go. Nope, this is just utilizing spread or object destructuring. All right. Awesome. Any other questions?
Yeah, I have a question real quick.
Let's hear it, Carlos.
So on line 77, you print days of the week. So when you slice it like that, it'll still return a tuple, right? It doesn't like turn into an array or anything like that once you slice it.
That's right. It's still
Okay. Okay. Gotcha. Yeah, because that was throwing me. I thought I heard you say that it turns it into an array. I think I'm just going crazy, maybe.
awesome. There's a chance I might have misspoken, but no, it does return a tuple. All right. Great. If there aren't any questions regarding tuples or arrays, we're almost at the hour mark, and I don't want to dive into dictionaries and possibly get cut off halfway. So let's go ahead and take a 10-minute break now, and let's come back at 10:05 to continue on with our complex data structures. Thank you so much, everyone, and I'll see everyone back here shortly. All right, everyone, we just finished speaking about tuples. Now let's go ahead and dive into dictionaries. Dictionaries being our last complex data type that we are going to work with today. Now, dictionaries work almost exactly the same as objects in JavaScript. They still provide instant access to values, but the biggest difference between these two is, or syntactical difference between the two, is you must utilize quotation marks close enough to establish your keys. Whereas an object, it was optional. In dictionaries, it is not optional. You have to ensure you utilize quotation marks. All right. Now, let's go ahead and start working within a dictionary or creating our dictionary. Just like we did yesterday, we have a car that we can create a dictionary for. Everything else looks pretty much the same. I'm utilizing curly brackets to establish this is a dictionary. And I can say, hey, this is a make of Ford. I'll have my model, which is a Focus. My year, which is 2012. And then mileage, which is 217,000. Nothing necessarily out there has changed here, or something that we should discuss any further as far as breaking down. We can still just grab information by grabbing it through the key and allowing us to have instant access to information. So for example, my car, and then I grab make. That would return Ford. If I go back and I grab the model, well, that would return Focus. Now, how do I assign a new value to my car? I could say something like my car, let's say tires or tire pressure. And I could assign this to 35. Well, now when I go to grab this value, you'll notice it returns 35. I've added a new key value pair to my dictionary of tire pressure 35 at that very end. Now, there's a couple of other differences here. In JavaScript, if I try to access a key that doesn't exist within my dictionary or within the object, what did it do? What was its response when I try to access something that didn't exist?
Undefined.
Yeah, it would return undefined. Well, we know that there's no such thing as undefined inside of Python. So if I were to pass in something like unexplained here, which we know doesn't exist, it would throw an error. It would tell me, hey, this key doesn't exist. Well, this is something that's breaking my code. And I'm not always going to know if every single dictionary is going to have the exact same key when I'm working with it. So maybe there's got to be a more flexible way for me to create a program in Python that will be able to access keys without breaking. That's where our methods come in for dictionaries. Instead of utilizing the square brackets to be able to access a key, I can say dot get. And by passing in dot get, if I try to grab a model, you'll see it still returns focus. If I pass in the year, that still returns 2012. And if I pass in something that doesn't exist, like unexplained, you'll notice it now returns none. It says, hey, this doesn't exist. So what we're going to return is none. Moving forward, if you're writing code in Python and you're working within dictionaries, I strongly recommend that you get used to utilizing the methods for accessing key value pairs rather than doing it through square brackets. All right. Does anyone have any questions regarding dictionaries? Let's hear it, Alex.
So does that mean that you can't have an integer as a key in a dictionary?
Yeah, let's try it out. Let's say that we do something like 22, and 22 is set to 22. Well, when past that, you can see that the integer is actually evaluated as a key, and it returns the value of 22. If you're utilizing something within words, or that is utilizing characters rather than utilizing integers, make sure that it is in quotation marks. If it's an integer that you're utilizing as a key, that's going to fly as an actual key, and it won't throw an error. I can see where the point of confusion was because I mentioned earlier that you must utilize quotation marks.
Yeah, thank you.
Of course. Any other questions? All right, perfect. Like everything else, there are dictionary methods that I strongly recommend that you take a look at. There's also different ways for looping through a dictionary. We'll go take a look at that later on. But let me go ahead and share this one here with all of us inside of the questions channel. Perfect. So now our dictionaries have been completed, and that is it regarding our complex data types. Are you drawing on my screen, Carlos?
Sorry, it didn't say that it was drawn for everybody. I was just checking it out.
All right. Perfect. Let's move on into functions. Now, functions, just like in JavaScript, are a repeated set of steps that may or may not take in inputs, that will always conduct an action, and may or may not provide an output. Now we're going to start talking about indentation. Go ahead and grab those 3 points there. Where are you at, functions? Here you are. All right, so here's our functions. May or may not take inputs, will always conduct an action, and may or may not provide an output. So for example, let's say we make a function. Well, now in order to create a function, before I was utilizing a keyword such as function. But inside of Python, it doesn't seem like that exists, or it's not able to recognize that keyword. Well, the terminology in Python is define a function, meaning that if I'm going to write a function, I would define it by utilizing the def keyword. I am defining the following function of add two items. This may take in an item 1, and it may take in an item 2. And then all it's going to do, maybe all it does is print item 1 plus item 2. Now, what would be the inputs that go into this function that we just defined in line 103?
What do you mean?
Item one and item
You
two.
haven't made them yet?
Yeah, so the inputs, what would they be that go into add two items?
You could add 2 strings, you could add 2 numbers.
Got it. So just to make sure, I apologize. Maybe my question was I should have refined my question. Just to ensure that we're all tracking, item one and item two would be our inputs for our function, right? Those are the expected inputs that we have for our functions, also known as parameters. Now, what's the action inside of this function?
Print.
Yeah, we have the print statement. What else is the action inside this function?
It adds the 2 parameters together, which at
Perfect.
that point they're called arguments once they have values, right?
Yeah, once they have values, those would be our arguments. But here we are going to go ahead and add them together and return that in the print statement. All right, and Cody, does this function return or provide any outputs?
It'll just log to the console.
So does it provide an output?
No.
Perfect. It wouldn't provide an output, right? Because it's not actually returning anything. So if I go ahead and call this function, I say, hey, add two items, and you'll notice that the way I invoke or call the function is exactly the same way as it was in JavaScript. When I do 5 and 2, and I go to execute my function has 7. Or my function call prints into my terminal the integer 7. But what if I assign it to a variable? Just call it variable x. And then I print x. What outputs do we expect to see in the terminal up to this point?
None?
None.
Yeah, so first we would see the number 7 because that's what's happening inside of the body of my function. And then afterwards we would see none because currently the function of add 2 does not return any values. So now when we execute our code, we get 7. That's from the body of the function. That's our action. But our actual return value or our output is none. Go ahead, Dallas.
I don't know if this is the time for it, but can you explain the difference between arguments and parameters?
Yeah, absolutely. So a parameter is when I'm establishing it here, right? In line 103, I am giving it 2 parameters, item 1 and item 2. And I can reference to them inside of the body of the function still as parameters. Now in line 106, when I'm passing in line 5, or when I'm passing in the integer 5 and integer 2, these are my arguments, right? I am giving them an actual face value, so at that point they turn into arguments. Does that answer your question, Dallas?
So you're saying that the item 1 and item 2 become arguments after you make those arguments down there on line 106?
Correct.
Okay. Yep.
All right. Any other questions? Perfect. If there aren't any other questions, then let's go ahead and make a separate function that is going to return a string. So let me go ahead and pass in the requirements here. I want you all to walk me through defining a function that takes in a name as a parameter, builds a greeting with the name included, and returns said greeting. How would I go about building this function? let's take the first step from Okino.
First, with defining the function. Well, first you use the def keyword, and then of course name the function.
So def keyboard, then what?
Name the function.
Okay, what do you want to name it?
Func. Bring in the func. I don't know. Then whatever parameters are greetings.
All right, so let's go ahead and call it name. Awesome.
Okay. Semicolon and colon. And of course you have to indent because Python defines the scope through an indentation.
Awesome.
And then of course whatever action we want our function to take, which in this case
Let me
would be the print
pause
out
you
and the
right there
greeting.
so I can pass it on to someone else before you get too
Sorry.
far. Yeah, great job though. All right, let's see. Let me go ahead and pass this on to Rahino. What would be next?
All right, so at this point, we actually have to build the greeting. So what we could do is we can create a variable. We could label it as greeting. And it will be set equal to an F string. So it'll be F, and then we can say hello space. And then we do open and close curly brackets. And within it, we'll put the name.
Perfect. So that's going to build our greeting. And then let me stop you right there and pass it on to the last step. So Dominic, what would be the last step here?
You go ahead and return that greeting valuable or variable.
Return greeting. All right, awesome. And then finally, Daniel, how would I go about calling this function and seeing its output on my terminal? You're muted.
So you'll do print. And then inside print, you're going to pass the greeting function. And then inside those, you're going to put whatever name you want to be greeted.
All right. But now we execute it and we get hello Carlos. We were able to build a function that conducted an action and provided an output. Fantastic. At this point, does anyone have any questions regarding functions?
I have a question, not necessarily functions though. Well, possibly. So you said that, Python depends on indentation to just, it depends on indentation. Does it necessarily have to be 4 spaces, or is it just basically as long as you follow the same thing just kind of throughout your code? Like if once you fall within a function or whatever, just kind of indent one more spot and then you're good?
Yeah, that's a great question. So there's a huge argument in the industry regarding this question. Some people say that double space is the correct indentation. Other people say that the tab key, which is essentially 4 spaces, is the correct amount of indentation. What I do is I actually have an extension, and let me show us this extension here. Here you are. And the extension that I have should be Highlands, I believe. Nope, here we go. So this one right here, you can see that when I click on main.py, I have this Python with these brackets here. Oh, here we go, black formatter. So I have a couple different things going on here, but this black formatter looks like is the one that's managing my indentation. Let me see if I have that available. Here it is. So this extension here is actually managing all of my indentation, and it's letting me know if anything falls outside of place or if anything is not following the same convention. And I will get a link here shortly and send it out to all of you. And basically what that allows me to do is now when I'm within my Python script, all I have to do is explicitly hold Command S to save the file, and you can see how my file changed. And all my indentation was automatically taken care of for me so that everything's following the same exact indentation convention. Does that answer your question, Carlos?
It does, and I'm assuming that's the command for Mac. I think Windows is Alt Shift F for format. Is that the same thing as doing the Control S or the Command S?
I believe so. What triggers this extension is every time the file is saved. So if you just want to save the file, Control S will save it, and that will format it.
Gotcha. Thank you.
Of course. All right. Awesome. Any other questions? Perfect. If there aren't any other questions, then let's move on into conditional flow. And we can start talking about comparisons and everything else here. All right, so conditional flow. Works exactly the same as it did in JavaScript. Only syntactical difference is there, instead of else if, there's elif. Right? Other than that, everything works exactly the same as far as writing the code itself. So we can see if true, I would print this was true. Else, this was false. If I go to execute my code, we can see this was true. Now, if I go back to changing that to false, we would see this was false. Now let's start talking about a little bit of comparisons here. While we're using comparisons, comparisons work exactly the same as they did in JavaScript, with the exception of the double equal sign. If I say if h, or excuse me, if the string 1 is equal to 1, what would that return?
False.
Yeah, this would return false. Now in JavaScript, what would this specific statement here return?
True.
True.
Yeah, because JavaScript is loosely typed, and if I'm doing a loosely typed comparison, it would say, yes, the string of 1 is exactly the same as the number 1. If I do a strictly type, which in JavaScript would be a triple equal sign, then it would return false. In Python, there's no such thing as a loosely typed comparison. So the moment I run the double equal sign, it defaults to a strict comparison, where it's not only comparing the value, but it also comparing the parental data structure from one to the other. All right. Now let's go ahead and do a couple of other operators. Let's say, hey, if 3 is greater than 1, well, that would also return true. And now let's say if -3 is greater than 1, that would return false. If we take this a step further, we could also say elif and pass a secondary condition. I don't even think these parentheses are necessary. Yeah. So elif 3 is greater than 1, then I can say print second option is true. And then we would get the second option is true. Now, when it comes to double comparisons, the keywords or the series of characters utilized to specify an or and have changed. In Python, it is plain English. We can say print if -3 is greater than 1, or if 3 is greater than 1. Then we can print first statement, or we can just say this was true. Now remember that or statement means either one, either the left or the right hand side have to evaluate to true in order for this entire if statement to be true. And we get this was true. -3 is not greater than 1, so that evaluates to false. But that or statement says, well, what if 3 is greater than 1? That evaluates to true. So my entire if statement in line 132 becomes true. Now, if I change this to and, my output would be quite different. Now I get this is false. -3 is not greater than -1. So it doesn't even take a look at my secondary condition. Once it says -3 is not greater than -1, it kills it and sends it straight to my else statement. All right. Does anyone have any questions over conditional flow? Let's hear it, Dallas.
How'd that work for using multiple ands or mixes of those?
You would just simply.
Same rule applies. You don't need any parentheses or anything. Or you
I would
do?
put them in parentheses at that point. If you're doing multiples, let's be doing.
Just because it makes it look cleaner.
I think you can have unexpected behavior if you don't have parentheses,
That's right.
because the order in which it evaluates things. So you can do it. It just might not do what you want it to do if your logic isn't perfectly correct.
Okay. So I should just stay in the habit of using them for this.
Yeah, so if you're doing something like this where you have multiple statements or multiple ands or multiple and ors, I would start nesting them within actual parentheses so that it knows what it's evaluating. Because otherwise the script might get confused and not know if what we're comparing is 3 greater than 1 or the length, and try to analyze this as one statement rather than analyzing this as its own statement and then this one as a separate one. All right, so once it becomes nested and gets a little bit messy like that, you want to start just adding those parentheses to make sure stuff gets isolated and it tells Python what needs to be executed and what is grouped together. Does that answer your question, Dallas?
Yes, sir.
Perfect. Any other questions? All right, if there aren't any other questions, then let's start talking about truthy versus falsy. All right, so just like earlier in JavaScript, we determined that anything that does not hold a memory allocation to it will evaluate to false. So with that said, there's a couple of commonalities. If I pass in 0, what would we expect on the to be the output?
False.
And we would receive false. If I pass in the number 2, what would we expect then?
True.
True, because it's actually occupying space, all right? If we go back and do an empty string, well, that returns false. If we do a string with characters inside of it, that would return true. Now, what about a floating number? What if I do 0.0? Well, that still returns false because in the end, it's 0. Well, what happens once I start adding actual decimals to it? Then it becomes true because it's no longer empty. It's actually holding a value. So our primitive data structures are pretty easy to tell if something's going to be truthy or falsy. If it holds a value, it returns information. It returns true. If it doesn't hold a value, it returns false. All right. Well, what about our complex data types? Let's say I pass in an array here, or excuse me, a list. If I go ahead and pass in a list and execute this in the terminal, well, an empty list returns false, which is what I expected. Now, what if I say hello inside of my list now? Now my list has a value to it. Well, now it returns true. You'll notice that this is different than what we saw in JavaScript. In JavaScript, the moment you created an array, it started occupying memory allocation, so it was evaluated to true. In Python, that is not the case. Once it holds a value, then it becomes true. And the same thing can be said for a dictionary. An empty dictionary would return false, whereas a dictionary with keys and values would still return true. Go ahead, Dallas.
How about an empty dictionary, or well, a dictionary with an empty list or empty string in it?
A dictionary. I think you're referring to a set.
Well, it could be anything else, like a list with an empty string in it.
A list with an empty string. Got it.
That is
That's
a value.
True, because the list is now holding a value. Now, list at index 0 would evaluate to false because that doesn't hold a value. But the list itself is holding a value of a string. All right. Let's try it out with a tuple. I expect the same behavior, right? Empty tuple gives me false. A tuple with information inside of it will give me true. All right. And actually, I don't even think this is looking at it as a tuple. Let me go ahead and do it this way. There you go. So now that returns it as true. And if I do just a tuple, it should return it as false. All right. Any questions regarding truthy versus falsy or conditional flow overall? Perfect. If there are no questions there, then let's move on into our loops and iteration. Loops and iteration. Now, loops are pretty much the same as far as functionality goes, but they do have quite a bit of syntax differences. So let me go ahead and grab the different loops that we're going to be covering today, so that I have them here easily accessible. And then we'll start covering each one of them. All right, so here we are. We're at loops portion. Now, if I want to loop through a list, let's go ahead and generate our list of foods like we had yesterday, where I believe we had pizza, we had pasta, let's say chicken. Let's say I can't spell chicken. There you go. Let's have some eggs. Let's have yogurt, some steak, maybe some potatoes. This is good enough, right? So there we go. We have a list here. Now, when I went into iterating through a list in JavaScript, what I did is I established a variable that represented 0, and then I incremented that variable by 1 at the end of every loop. Now, it doesn't work the same in Python. I could mimic something that does that, but I would be doing it, creating a while loop, and that's not what we want, right? We don't want a while loop. Instead, what we're going to utilize is something called the range function. Now, the range function actually returns a value. So let's see what the range function does here. I'm going to pass in range, and then I'm going to pass in foods as my argument. Foods list object cannot be interpreted as an integer. Excuse me. There you go. We would pass in the length of the foods, right? And then it gives me, hey, this is just range 0 to 7. Well, what does that mean? It's not really telling me much as far as what exactly that's representing. Here I have index 0, index 1, 2, 3, 4, 5, and 6. So maybe this is inclusive and exclusive, just like we talked about before, where the last number would be excluded. But even then, what does 0, 7 mean? Well, if we wanted to take a look at the entire act or at a readable output of the range function, we'll actually have to convert it into a list. Now let's see what that returns. Okay, so the range function actually returns a list with numbers inside of it, where the numbers start at 0. They don't always have to start at 0. I can also pass it something like 2, comma, and then the length of my list, and you can see that it starts at 2. So it takes in 2 arguments, where the left or the first argument, excuse me, the first parameter, the first argument, I apologize, is going to be inclusive, and the second will be exclusive, right? So there we can see 0 to 7, and that goes 0, 1, 2, 3, 4, 5, and 6. So that's what the range function does. And that's what allows me to move through this list. Now, what do I mean by move through this list? Let's do a for food in foods. And I want to print food. This is similar to a for of loop inside of JavaScript. It iterates by value and returns the value of each one of those items or each one of those indexes. But it doesn't give me access to the index. So if I wanted to have access to the index, that's where the range function would come in. I would utilize the range function to create a list of indexes that I can then iterate through and call by each independent index. I would say for food, or actually, let me just comment this out. I would say for IDX, which stands for index, in range of the length of the list of foods, I want to print IDX. And now we would get a series of 0, 1, 2, 3, 4, 5, and 6, which also allows me to take it a step further and call the list of foods at index to return each independent item. So this is iterating by index, and here above, we iterated by value. Does anyone have any questions regarding iteration by index? Perfect. In that case, let's start talking about the enumerate function. Well, before we start even writing this for loop, just like we did with range, let's understand what enumerate does. I want to print enumerate and pass in my list of foods here. Well, enumerate actually creates a class instance or an object of a class instance, which kind of doesn't help me as far as iteration goes. What exactly does enumerate do under the hood? Well, what enumerate does is it goes through the list and it returns an array of arrays where it holds an index plus the value. So in this case, it would be pizza. That would close it. The next array would be 1 and pasta. The next array would be 2 and chicken. And so on. Well, if I know that's what enumerate does, I can utilize destructuring to grab each one of those pairs and assign them to variables. So now I can say for index, which I know that's going to be the very first pair inside of that list, comma food, which I know that's going to be the second within the list, in enumerate foods, and I want to print IDX, comma food. And now in my terminal, you can see that I get that 0 pizza, and I apologize, I accidentally pressed an extra key. There you go, we get 0 pizza, 1 pasta, 2 chicken, 3 eggs, and so on. And that's how you can iterate and have access both to the index and the item at the very same time that you're iterating through a list. Does anyone have any questions about that? Go ahead, Dallas.
Yeah, so you have a list of lists there you're using for enumerate, right? Is it all on food and enumerate foods? Okay. Are you able to do that with just foods without that enumerate return, or am I just missing something here?
So the enumerate return, what I'm doing here is I'm mocking or I'm mimicking what's actually being returned by the enumerate method. This is
okay.
representation of the return value of enumerate.
Okay, I get it now.
Any other questions? Perfect. If there aren't any other questions, then let's move on into iterating through dictionaries. And let me go back and grab my car dictionary here. All right, so dictionaries, iteration. I can do something to iterate through the dictionary where it will just grab immediately the keys. Just like a for of loop was just grabbing the values. This one would just iterate it and just grab keys. So I can say for key in my car, print key. And just like that, I would have access to the keys and the keys alone. That was pretty straightforward. If I wanted to grab a value, I can just say print my car.get key. And by doing so, it would print the key and then that value. All right. Now there's a way to just grab the values themselves. Just like I could iterate through only the keys, I could also change it so that I only iterate through the values. Let's go ahead and print my car dot values and see what that method returns. Well, when I do that, what it returns is a list of all of my values. So that means that I can say for value in my car dot values and print value. And that's how I can iterate through a dictionary and only grab the values. And then for the final portion of our dictionary, if we want to grab both the values and the keys, I can utilize something like dict.items. So let's see what .items returns. Well, now we have a list of tuples. just like the enumerate function returned a list of list, the items method returns a list of tuples, where each tuple holds a key value pair. The key being at index 1 and the value, or excuse me, the key being at index 0 and the value being at index 1. So if I had to grab this information, I would say for key, comma, value in my car dot items. And from there, I can print a key. And I can also print the value. And just like that, I was able to iterate through my entire dictionary and grab both the keys and values. All right, let's open it up for questions regarding iteration. Nick?
What is the dict underscore items wrapper around the list of tuples right there in your terminal? Yep.
Got it. So this is a class object. So
Okay.
everything inside of programming is going to be a class. Inside of Python, there is a class named dictionary, and in there is a property named dict items. That property essentially breaks down all dictionaries under the hood to be a list of tuples. So when you go ahead and utilize something like dot items or even something like dot values, which you can see here returns dict values, these are just different properties that belong to that dictionary. So when the dictionary is constructed, all of these items also get built out for it, but you only have access to them or you can only invoke them if you call the property through their method. That might have been a little too in-depth, but essentially this is just.
And we don't have to do anything special. The fact that it's returning that out in front, we just treat it like a regular list
It's nothing
of
special.
tuples.
Yeah, it's nothing special.
Okay.
What it's returning right now, it's this is a formatted string that it's returning. It's not actually a representation of the data. The
Okay.
representation of the data is the list of tuples. All right. Any other questions? Dallas, I believe I saw your hand up.
Yeah, I don't know how to phrase it yet, so I'll just think about it later and get back to you.
Okay, perfect. All right, everyone. We have one more portion to go through here, and that's going to be our intermediate Python function here. At this point, we're going to go ahead and take a 10-minute break. Currently, right now, it is 10:54. Let's go ahead and return at 11:05 to continue with the last portion of our lecture. Thank you so much, everyone. All right, question, Dallas, let's hear it.
Yes, sir. So I stared at it for a bit and thought it over for. I see there, line 167 on down. There's the key in, and then your dictionary, and then below that was the values, and then dictionary dot values changed, and then yeah, there it is, for key comma value in your dictionary dot items. So is that like what you're doing with enumerate earlier, where that was just a more progressed version of how to deal with dictionaries with for loops, so I can access more things easily with this on 177?
Yeah, so we're saying the dot items portion. That's correct. So dot items would work similar to the way enumerate works, right? Where enumerate returns a list of list, dot items returns a list of tuples. And yes, it would just essentially give me more access, right? Because now I have the ability to access a key in case I want to change the value. So let's say I want to do some conditional rendering saying, hey, if this key meets the following, then leave the key alone. And if it doesn't, then I want you, or excuse me, then leave the value alone. And if it doesn't, then I want you to access this key and give it a new value of this, right? Now it gives me that ability to run all of that logic without having to do more of this that I did in 169, where I have to grab the key independently or grab the value independently and then run the logic. It's just giving me more access to more information in regards to the dictionary.
So is it fine if I rely on 177 to form my for loops for dictionary dictionaries instead of using the key in my car on 167?
Absolutely. Yeah, I would
Okay.
take that point. It's not going to hurt you as far as performance goes in bigger picture. I mean, this one is definitely going to be your most, when it comes to performance wise, this one's going to be the easiest or the one that occupies the least amount of space.
Mm.
But when it comes to logic wise, which I think is what we should be worrying about now, I would absolutely recommend you just sticking to this, right? Because then it gives you access to both of them. You know what's the key, you know what's the value, and you know what you're iterating through.
Will do.
All right, perfect. Any other questions? Nice. Now that there are no other questions, then let's start talking about some intermediate information here. Starting off with switch cases or match cases. Now, match cases are essentially if statements with a default out, otherwise known as else. Now, when you create a match case, let's go ahead and make a variable here. Let's say my number is equal to 10, right? And I want to match the following conditions. Well, when I'm calling match, what I am matching, it's asking what is it that the input is, or what is it that we're going to be comparing against the following cases. Well, what I want to be comparing is my num. And then it starts asking me, well, what are the cases, right? So in case that my num is, let's say, greater than 11. Oh, interesting. Let me actually follow a different example here. Let's go ahead and take in some input. And this is going to be good because we actually got to learn a little bit about input. Let's say my subject, or call it user subject. What we're going to do here is we're going to ask for input from the user. And we're going to see this in the terminal where we're going to ask them, what's your favorite programming language? And ask for their input. After that, I'm going to go ahead and print this user subject. Let's execute the script in the terminal now. You'll see that I get an output there, or from my print statement, I get what's your favorite programming language. Now you may think that this is happening at the print statement down here in line 188. It's actually not. This string is coming from the input function. Now I can actually provide a value. I can say, oh, well, it's Python. In my case, you'll see that I typed in Python into the terminal and pressed enter. This now becomes the return value for input that gets assigned into user subject. And when I print the user subject, that's when I get that final Python line down below. All right, I am essentially capturing my user input through the terminal, and I'm able to see that output or capture it and place it inside of a variable so that I can reference it in some sort of output or logic later on in my program. Does anyone have any questions regarding the input function before I continue moving forward? All right, perfect. If there are no questions, let's hear it from Alex.
Is there a different way to ask for an integer as an input instead of a string?
No, so when it comes to handling integers, you're just going to have to capture them through the input method as well, but you can cast them into integers, all right? What I would do is I would always check if it's numeric, the input that I receive from the user. If it is numeric, then I would cast it, and if it isn't, then I would ask the user to place their input again. Does that answer your question, Alex?
Yeah, that's good. Thank you.
Of course. Any other questions? All right. So now I have my user subject, or I'm able to capture my user subject. Now let's create our match cases here. Now for my subject, or excuse me, the user subject, what I'm going to do is I'm going to match it where the case is that the user has placed in Python. And if that matches, then what I'm going to do is I'm going to print the user chose Python. If they chose the case of JavaScript, let's go with JS for shorthand, then I would print the user chose JS. And then finally, my default statement, which in this case, the way we establish a default statement would be with an underscore, where I would simply print they like a different language. All right, I saw a hand go up, so before I execute this code, let's hear it from Michael.
Are the cases case sensitive? So like if they put lowercase p Python, it would go to the underscore case?
They are, yes.
Okay.
So a good way to fix that, or a good way to address that, let's say that you didn't want to have to worry about capitalization or too much sensitivity regarding the user input. Well, what you can do is you can grab the string and just flatten it. You can say, hey, I want this to be lower. And regardless of how many capital letters I put in there, it's always going to turn it into a lowercase string. Awesome. Carlos?
So does each case they can only have one value? Can you do an or? So for like for example JS, can you do JS, maybe they actually typed out JavaScript?
No, each case has to have one matching case to it. That's the limitation there.
Thank you.
Of course. Any other questions? Okay, perfect. Let's go ahead and execute the script now. So what's my favorite programming language? I'm going to go with Python. And we can see the user chose Python. If I go ahead and execute the script and I place in JS, you can see the user chose JS. And if I execute the script one last time and I type in a bunch of gibberish, I get they like a different language. All right. Any questions regarding match cases?
What's the advantage over using just a whole bunch of if statements? Is it faster? Easier to read?
Not necessarily. When it comes to the advantage, I would say that the comparison that's already happening, we know that the comparison that's happening is a strict equals comparison. All right, so at every level, it's asking, hey, does user subject equal the following? Now, other than that, I would say syntax, just making sure that it's identifiable rather than having to write over and over if and then using the same exact attribute to compare something. So if you're always utilizing the same attribute for the comparison statement or the conditional flow, you could just put it inside of case statements, right? Rather than having to rewrite it over and over again. You don't want to repeat yourself. And it also makes it good as far as code readability goes. Other than that, performance-wise, nothing really changes. Same exact way as an if statement. It's literally coming to a gateway and it's saying, do I go left or do I go right? Does that answer your question? Perfect. All right, let's move on into Lambda functions. Too far up. I think I left. Yep. All right, so Lambda functions. Lambda functions are similar to arrow functions in the fact that they can actually have a default return statement. So if I want to write a Lambda function, I can have something like EF, we made it earlier, add a 1, right? And we have X, which should always be an integer. So let's just call it num. And what we're going to do is we're going to return X plus 1. Pretty simple function, right? It takes in one parameter, and then after that, we just add 1 and provide that as an output. That's its entire reason for living. How would I write this as a lambda function? Well, if I wanted to write this as a lambda function, all I would do is say, hey, I have a variable called add a1. Now I want to assign this to lambda, where I will accept one input or one parameter, which is num. And to this one parameter, I want to add 1. Right? There's all I'm doing here, we have add 1, which is the name of the function. We have the num being the parameter. Here's where I define the parameter. And then we have our action, which is being defined on the furthest right-hand side, all in one line. And this will be the assumed return value. Now, unlike arrow functions I can create an entire body. Lambda functions I cannot. With lambda functions, the only reason why I should be creating lambda functions if I know how to write in one line the execution and return value. All right, Carlos?
You answered it already.
Perfect.
The difference between that and the arrow function.
Awesome. Any other questions regarding lambda functions? Okay, so now that we understand lambda functions, let's go ahead and start applying them to something like a map. Well, in map, just like we did in JavaScript, when we mapped through a list or an array, I apologize, that took in an arrow function so that it knew what to apply to each one of the values within the list. So now if we apply this here in map, I can say mapped return. And I can assign this to a map function. Inside a map, I'm going to specify what is the function that I want to happen. So lambda, my arrow function, right? I am going to pass in a food. And for every food, I want you to return the food in uppercase. Okay, so there's my function. I'm essentially just churning every food inside of that list into uppercase. But as of now, I haven't told it what food I'm talking about. So now I'm going to pass it in and say foods. So now it knows it's going to iterate through the list of foods For every item, it's going to grab it, turning it into an uppercase, and then put that into my mapped return. I can print mapped return now. You'll see that that returns a map object. So if I wanted to see it back in the original setting or back as a list, I just have to recast it back to a list. And there you can see that we have pizza, pasta, chicken, eggs, and so on, where all of the letters are now uppercase. Does anyone have any questions over how we did that or what the map function is doing? It's still working exactly the same as it did inside of JavaScript. It's just different syntax, but the actual functionality of it is working the same. Questions regarding map? All right. Well, if we understand the map function, then let's move on to the filter function. Again, we're going to do filter return. We're going to utilize the filter function. Now for the filter function, same thing as before. I'm going to pass in a lambda, which is the equivalent of my arrow function. And I'm going to say, hey, for every food in here, I want to return the food if the food dot length, or let's just say food dot contains. Let's see. Now I need to remember my Python string methods. Let's take a look at what we have here. Let's go over to strings, go over to methods, format, index, is out num, is digit, is upper, is title.
Maybe it's the find one, find method.
Specified value. There you go.
What are you trying to do?
Fine. There you go. Fine. Got it. Thank you. I apologize. So searches the string for a specified value and returns the position of where it was found. All right. So that position of where it was found would either evaluate to 0. Maybe I want something that's just a Boolean instead. Let's do a better example here. Let's do if food.
Can you do is in? Like if you want to get all the foods with an I in it, you do the string I space is space in food.
Oh, that's a good question. Yeah, let's try that.
So I'm thinking,
let's see if let's go with A.
Sure.
Yeah, A is in food. Nope, looks like that did not work.
That's right. In.
So if the A is in food for the array of foods, then it'll return it. Let's go ahead and print that out. Print filter return. All right, so again, we get a object. Let's turn it back into a list. And there we can get pizza, pasta, steak, and potatoes. If I want something even smaller, I can check for I, which I believe only one of them will have it. Oh, 2 of them. And now we have chicken and pizza being returned. All right, so it works exactly the same as filter in JS, just syntactical difference. All right. Any questions regarding the filter function or the map function?
So the syntax is for filter lambda variable name colon, then some condition, comma, the array you want to filter.
Correct.
Is that right? And then it returns the filtered array. Okay.
That would be it. Any other questions?
Could you use regex expressions where the I in food is at?
You can, as long as the statement after the colon evaluates to true or false, then you can place it in there. All right. The last thing we're going to be covering today before we move on to part 3 this afternoon is going to be our try and except block. So try and accept blocks. This is called error handling. And it's utilized to ensure that essentially that your code won't break. And that if it does break, it's for a specific reason. Right? We don't want your code to just essentially break and crash. We want it to break, notify us that it has broken, and for us to have a way to continue moving forward. So let's do this. We're going to go ahead and try the following. I'm going to try to have my variable. Let's do a couple of variables. Let's do A, which is 1, B, which is a string, and then let's do C, which is equal to 5. And then finally, let's assign a variable. So result is equal to A plus. Let's take it out from the try block for now. Let's save it. And execute this code. Well, when I execute this code, I get an error. It tells me, hey, in line 215, you're trying to add A plus B, but that's an integer in a string, so you can't do that. Okay, well, I expected that error to happen. This actually crashed my code. I don't want that to happen. Instead, I'm going to write a try block. And for that try block, I'm going to try the following. And a better example would be to do this. Now, if that fails, I want to accept my exception as E, print E, so I can see what the exception was, and then say result is equal to A plus C. Now, if we run it, at the very end, let's go ahead and print result. Well, let's make result be equal to. All right, so currently result is non-existent. I'm going to try to assign result to A plus B. If that doesn't work, I'm going to see what the error was by printing my exception. And then I'm going to have result be A plus C. So I try it out. This initial line of code raises an error. Instead of breaking my code, it falls into my exception block. I capture the exception by calling the exception keyword. And this as E is just saying, I want to capture the exception and set it to the variable of E. When I print E, that's what I see down here of the unsupported operand. I cannot add an integer plus a string. And then I assign result to the value of A plus C. Print it. Now, this is an example, a very basic example. This could definitely be handled with an if and else statement, right? Where I'm checking if one of these is alphanumeric, or both of these are numeric, then conduct the addition statement. Else, do the following. What's important to capture here is that we were trying to execute a block of code. Upon that block of code raising an error or raising an exception, we were able to catch that exception and have a backup plan to how to handle the logic for our code. All right, Michael?
Could you use this exception formula, like exception as E and then print E, in a if-else statement?
You cannot. You can't
No.
capture inside of an if-else statement.
Okay, so the try and except comes up with an error, and that's what you're capturing with the exception?
The try is what captures what comes up with an error, and that's what I'm catching with the exception. Yes.
Gotcha. Thanks.
Of course. Go ahead, Daniel.
So instead of basically making a class of E and then putting in that it inherits the exception traits, you can just cast it as exception as E. But could you also raise that could you now raise E as an error? Like if you're making your own error statements?
Yeah, you definitely can. You could say raise exception and then pass an E. Or you can just say you did something wrong. All right, so that
So now you don't even.
it tells me you did something.
So now you don't even have to develop a class and then make a variable inherit any exception. You can just typecast the class itself.
Yeah, you can make your own you can make your own rather than capturing it. You could just, hey, I caught the exception. This is the exception that I want to raise. Maybe the exception that gets raised by Python isn't specific enough to know what's going on, and I want to specify something better. Well, I can make this tool to actually tell me, hey, you did something wrong. And I would also maybe specify this exception is being raised from this file. This is likely the mistake that you're making. So that when people get the error, they know what's going on.
Thank you.
Of course. Dallas?
For raise, I haven't seen that before. Is that something we use just in exceptions?
Raise is utilized to bring up different types of exceptions. That's the most commonly used way for it. I believe it does have another handle, but I can't remember it off the top of my head. I'll have to look it up and get back to you. I apologize.
It's basically just for exceptions among most people.
Correct.
All right.
All right. Any other questions? All right. If there aren't any other questions, then let's go ahead and pause here. You can go ahead and pause our recording. All right. Welcome, everyone. Now we're going to go ahead and start talking about our actual test-driven development portion. Now, within test-driven development, we're also going to cover a couple of other things. We're going to go ahead and cover how to export and import information from one file to another. And we're going to go ahead and cover what a Python module is and what it stands for or how it works. We're not going to go too deep into Python modules, just like NPM, but we will get a very basic understanding on how to create our own modules here. So first things first, all of you should already have a environment named default. I'm going to go ahead and activate mine. And now I have my default Python virtual environment that has been created. We'll talk about virtual environments shortly here as we move on into the next couple of weeks. Well, now that I have my virtual environment installed, I'm going to go ahead and create a directory for all of my tests. So I'm going to make dir tests. I'm going to change directory into, actually, let me change that here. Into test demo. We'll call it demo. change directory into demo. Here I'm going to clear the information in my terminal. And inside of demo, I'm going to make two separate files here. The first one being my actual main file. So I'm going to call it main.py. And my second file being my test.py. So there you can see I have two separate files. Both of them have py. Notice that there's no pattern for my test suite where I had, as like yesterday, where I had something that said .js, .test, or .spec, .js. No, there's nothing like that. Here, we're just simply creating our files. Now I'm going to go ahead and make a function here. This function is not going to do anything crazy. I'm going to go ahead and make a function that will just multiply things to the power of 2. Or let me see if I could come up with a pretty simple function here. I guess we could always stick to our say hello function, right? Stick to our say hello function that returns hello. Now, I want this function to be able to be exported and to be accessible into different files within the directory of demo. But I don't necessarily know, or test.py doesn't necessarily know that it has some sort of tie-in with main.py. Yesterday, when we created an npm package, npm is what created our module and created this block within our directory. Well, now, inside of Python, in order to create that same habit or that same effect of having a block within our directory, what we're going to do is we're going to create a file called __init__.py. And this tells Python that now we have a module that's living within this directory, meaning that information can now be shared between main.py and test.py and any other nested directories within this demo. All right, so that makes our Python module there. Does anyone have any questions over init.py up to this point? Well, now let's go ahead and do our whole importing. Well, before, when we talked about importing, what we did was we were actually grabbing information from a file and asking for that file later on. Well, in Python, it's actually a lot easier. Once things are modularized, we don't have to export a function. That function is available to all of our other files. Well, that means that inside of test.py, I can say from, specify the file, which in this case, it's main. I want to import, say, hello. And just to clarify, I'll go with .main. So from this current module, there is a file that has been labeled main, and I want to import the function say hello. So now I can actually call that function from this file. So I can say Python 3 or Python test.py. Oh no, let's try that again. There you go. So from main, we imported say hello, and that's how we were able to get it out into our print statement, everyone. All I did was remove that period because now that we're modularized, we don't need the period to begin with. All right. Any questions regarding importing functions from one file to another? Let's hear it out.
Can you just select the main.py so I can see all that again. Okay, thought so. That's all. Thanks.
Of course. Nick?
If I want to import, let's pretend there's 20 functions inside main.py. If I just want to import them all instead of just say hello, can I just say import main
You could
or import dot?
That's a great question. So you can actually just import wildcard. And
Okay.
by padding in that pound sign, it will make all of them be imported into your file. Daniel?
And what's the benefit of doing the init.py, whereas you could just do from main.py, import whatever function you want, and it'll navigate to that as long as it's in the same directory?
When you're working within something like the simple examples that we're showing now, you don't necessarily need that init.py, right? Because you can always describe a relative path and try to find it, or even describe an absolute path. But once we're working within projects and start working where files need to be isolated and behavior to be able to accomplish some sort of task needs to be isolated inside of one directory, that's where you'll actually need to make sure that you worry about modularization and make sure that one thing is that one module knows and it's aware of what files and directories belong to that one module. Does that answer your question?
Right. Yes, it does. Thank you.
Awesome. Any other questions?
Can I see that init.py one more time?
Absolutely. Init.py is completely empty.
Oh, okay. I just wanted to be sure.
Of course. Now you'll notice that once we actually executed the code, we got this PyCache. And this PyCache is something that Python does. Not necessarily sure what exactly goes in there. I'm actually gonna have to refresh myself and figure out what exactly that PyCache is withholding. I do know that it's encoded code that's not necessarily readable to us. It's just going to show as special characters. I think that has something to do with the fact that it's running C under the hood and it's keeping it there as the cache. But I'll have to find out and then get back to everybody as to what exactly is going on there. Just know that ideally you wouldn't want to push this PyCache directory into GitHub. So keep that in the back of your mind. We'll go into how to handle what gets pushed into GitHub later on.
Is git ignore?
It will be with the git ignore. Yes. All right. So now I know how to export files. Let's take this even a step further and go into pathing, right? I'm going to make a directory. I'm going to name this data. And inside of this directory data, I'm going to go in there and write a CSV file. So I'm going to change directory into data, or even better, I'm just going to make a example.txt. And here you can see that example.txt has been opened up, but there's nothing in there. Well, let's go ahead and write something into the example.txt by creating a function in main.py. This function is going to take in a path to a file. And we're going to quickly cover how to actually interact with a file right now. So when we're interacting with a file, what we're going to utilize is a special keyword with open. And what this is going to do is it's going to open up a file and also automatically close it. If you only utilize the open keyword without the with, the file will remain open as long as the script continues. If you utilize the with keyword, the file will close as soon as the with block is ended. So just for common practice, utilize with open whenever you're working with files, you're trying to read or write into one another. All right, so now with open, I'm going to go ahead and open the path to my file. From there, I am going to specify that what I want to do is write. So the open function will open up a file. It takes in two parameters. One, where the file is located, Open function takes in 2 params, 1 where or location of file, and 2, it's going to be the verb or action to file. All right. This is going to open up the file and make it available to me. But I do have to have a way to reference it. Unfortunately, with the open function, I can't do something like my file equals. That would actually return an error. But there's got to be a different way that I can give it a variable that I can reference to later on to grab this file. That's where the as keyword comes in. So I'm going to name this as my data file. So as keyword assigns the file itself to a variable. Now that we've opened up the file, and all I want to do is write, I'm just going to go ahead and write into it. And let's make sure that we understand this portion here. Let's do write into a file Python. All right, so Python file write. Okay, so it looks like we just need to call the object and then write straight into it, right? So now we do data file dot write, and we can specify what it is that we would like to write. So I'm just going to write hello Avenger. Well, let's execute this function. And actually, before we execute the function, let's start talking about paths here. To work with paths within your operating system, you'll need to import OS. Now that's going to make OS available to your entire machine. And OS just stands for operating system. This is a set of tools that has been set for you to interact with your actual machine utilizing Python. Now in OS, I can do something like get CWD. This stands for get current working directory. If I go and print this into my terminal, you'll see that I get my entire working directory there. It's returning what kind of path to this file?
Absolute?
Yeah, an absolute path. All right. Well, what if I wanted to get something like a relative path? Let's take a look here. A relative path, I wouldn't actually need to utilize this OS system, right? I could simply write it. I can say, hey, from main.py, when this gets executed, you're going to go inside of this directory into data and grab example.txt. This works here. But let's take a look at a different example here. Let's say that I wanted to create an absolute path to a relative location, which is something that you're going to find yourself doing in Python pretty often. So I want to create an absolute path to one specific file. Let's say if I pass this into my function, I'm going to call my write into file function and execute it. All right, it seems like it was executed successfully. And now in my example.txt, we have hello Avenger. we were able to go into the directory of data, enter example.txt, and write straight into it. Great. Well, let's start talking about how we would build an absolute path from a relative path. I can also grab os.absolute path, or excuse me, this is going to be .path, .abspath, and then pass in data example.txt. And when we execute that code, we would receive the absolute path that takes us all the way down to example.txt. All right, any questions over this write to file function? Perfect. If there aren't any questions, I'm going to go ahead and return true from this function if it's successful. So I'm going to go ahead and put it inside of a try and except block. That way I can know if my function was successful or if it failed. Go ahead, Carlos.
Sorry, it took me a second. So what exactly was the difference? I mean, the paths look the same to me, the apps path and just the OS path. They look the same. Did I miss something?
The apps path and the OS path. So this is the absolute path.
No, but I'm sorry. What it actually returns. Oh, never mind. Never mind. I see it. I see it.
Okay, perfect. Any other questions? All right, perfect. Now that there are no other questions, we're going to go ahead and dive into Pytest. But before we do so, let's take a short break to try to refocus and understand that we're moving into a different concept. And let's come back at 2:30 to go straight into Pytest. Thank you so much, everyone. And I'll see everyone back here shortly. All right, welcome back, everyone. Up to this point, I have a couple of functions that have been written inside of main.py. I was able to import one of those functions into my testing file here that I know is a testing file because I wrote test, right? And then earlier I mentioned how there wasn't some sort of file convention that Pytest was going to be looking for, and I apologize, that was wrong. Pytest will be looking for files that begin with test. So when you're creating test files, you want to do test underscore and then name whatever you want to name them if you have multiple files, right? But test is going to be the pattern that Pytest will be looking for to identify test suites. Now, let's go ahead and write our very first test, or let's just go ahead and dive straight into what is Pytest. Now, Pytest has become a very popular testing framework, just like Jest, for writing unit tests. And it's able to interact with a lot of popular Python languages or even frameworks. For example, if I want to make a Django application, I could utilize the Django test suite, or I can actually alter the Django settings to be able to run Pytest as my default test suite. So let's start with a quick installment here. I'm going to go ahead and pip install Pytest. And when doing so, you should get a pretty similar message to what I got here. I was able to install Pytest, and then I get a notification here telling me, hey, the pip that you're currently using is outdated. You may want to update your pip. So I'm going to go ahead and take care of that as well. I'm going to pip install -- upgrade pip. I'm going to go ahead and share this portion of our curriculum into our chat so that everybody has these commands available to them as well. Now that I've upgraded my pip, I'm going to go ahead and reinstall Pytest because I want to make sure that Pytest has been installed correctly into my environment. I'm going to pip install Pytest. Okay, it tells me all my requirements are already satisfied, and I'm ready to go. And just like that, I've successfully installed Pytest. Now, how do I know if I could use it inside of my example? Well, here, I'm going to actually import Pytest. Just like that. We're not going to add anything else to it. We're just going to simply import Pytest. That lets Pytest know to expect actual tests within this file. Well, now let's just simply run Pytest in our terminal and see what happens. Well, when I run Pytest in our terminal, you can see that it goes through. It tells me, hey, I collected 0 items. I don't see anything that you need me to actually run any sort of assertions against inside of this demo directory. Okay, so let's take it a step further and actually write a function or write a test here where my test will be ensure say hello returns string. Now, all I have to do is assert type say hello is equal to a string. All right, let's see what this does. I run Pytest and it seems to still be unable to collect any items. Interesting. Oh, I know what I'm doing wrong. I apologize, everyone. Little bit of a naming convention error there. I need to make sure that test is at the beginning of the actual test itself. Interesting. Well, now I'm running into somewhat of an unexpected error. I apologize, everyone. I'm going to go ahead and pause the recording here. Yeah, everybody. All right, so after doing a little bit of research, found out that we need to actually do a couple of other things to Pytest to make sure that it's able to understand that it's working within a modularized environment. I believe Keegan brought up to my attention that it turns out that there's a pathing issue within Pytest where it becomes confused once working within different module environments, especially if this module is one that was created by your own or by yourself, like we did today. Other frameworks, when you go and create some sort of directory or a different module, this information is going to happen under the hood. And you won't necessarily have to input this pathing issue or handle this pathing issue on your own. But for this example, since we created it ourselves, it turns out that there is an issue for Pytest to be able to identify, hey, where is it that I'm supposed to work? And where is it that I can find files? Well, 2 things needed to happen. One, and probably the most important one, is change the naming convention of your file here to test underscore followed by some sort of description as to why it's testing, what it is that it's testing. So there's 1, naming convention. 2, ensure that you create a pytest.ini file. This is just going to be pretty much the same as a test file. But this pytest.init, what it does is it contacts Pytest. And whenever Pytest is being initialized, it's taking a look at all of the different configurations or settings that you added into this file. Kind of like that .zshrc profile does with the terminal. This is what's happening here, right? This pytest.init talks to Pytest. And in this pytest.init, all we need to specify, hey, within this directory or within this module, this is where I want you to look and find all of the tests that I have created. Now, upon doing so, when writing Pytest will take a look at this pytest.init. We'll see that this is where the settings regarding Pytest start. Pytest will see, oh, you want me to work inside of this path? Great. Let me take a look inside of this directory and find something that starts with test underscore. If found at test underscore, we can see that test.main.py was the test suite that was executed. And now in test.py or test.main.py, we were able to test, ensure, say hello, return string. As of now, it just says return string. But now we can import that say hello function and assert that type say hello is equal to a string. I go ahead and execute Pytest again, and now I receive an error, which is coming from my try and accept block, it looks like. Oh. That is going into the wrong file. And there you go. So from this directory, I want you to go into the main file. And in there, I want you to go ahead and grab the function, say hello, and execute it in test.main.py to ensure that the test is correct and it brings in a string. All right, that was a lot that I just covered. So let me go ahead and pause here for some questions. Nick?
So right there from .main, that's saying from this directory versus before when you didn't have that dot there, it picked up the main one directory up. Is that correct?
That's correct.
Okay.
All right, any other questions?
Is your import going to import any directory within the project? Like say you have another directory even higher up. If you do import from higher directory or from directory higher up, import this function, it can still see that?
It can only see that if you specify the path to it or if you call it as a module. Because of this init.py, we can see that there's a PyCache also on the outside. And this might be happening because of the way that we specified Pytest as well. It's identifying this as a module and demo as its own module. So pretty much anything that's modularized, that's what it's going to pick up.
Oh, because that's where you installed Pytest.
Exactly.
Okay, got it. Thank you.
All right. So now we're inside our demo. We were able to run our very first assertion. Let's run another one. Let's see what happens if we want to see one that will fail. We want to test that say hello. We want to test that say hello can take in a param. Oh, this is something different. Say hello is not an integer. Here I can assert again, where I'm calling the type of the say hello method. And then I can say is not an integer. If I pass in equals to integer, we're going to see this fail when I run my Pytest. You'll notice that a green dot stands for passing and a capital F stands for failing. it's going to break it down as to where exactly it is that I'm seeing some error. So what's coming back is where hello is equal to say hello. And it's letting me know, hey, doesn't match, because what we're asking is if this is an integer. But what we're getting back as the value is hello is a string. So my assertion says, hey, I have a class string which is not equal to an integer. So all I simply have to do is make it not equal, and that would get my test passing. And I see a question from Michael. Let's hear it.
You're being very deliberate in naming your test function. Is that standard practice? Like something we should work on?
That's a great question. Whenever it comes to the difference between Jest and Python, in Jest, I was able to describe the file that I was in. I was able to describe what it was actually testing and what I was expecting, right? Well, in Python, we don't have all of those blocks anymore. So naming your function or naming your test becomes extremely important. You could look at tests as almost a living documentation. If you just read tests as well, you can understand what each portion of the project or each portion of your project is actually accomplishing.
Okay, that makes sense.
Yeah, a complete stranger who picks up your project needs to be able to read your test suite and understand what it's testing and its purpose. So just common practice, try to be as deliberate as possible whenever you're writing your naming conventions.
So most of the time when you're testing your code, you're going to have a test file with a lot of individual tests included in it, and that's why being deliberate makes things easier.
Exactly.
Okay, gotcha.
All right. Now let's take this a step further and take a look at something a little bit more difficult. In main.py, I'm going to create a function that will capture or what is favorite subject. And all this is going to do is ask my user for their input. Saying, what is your favorite subject? And I expect it to return the favorite subject. All right, pretty simple function. I go into test.main.py and I want to import test favorite subject function returns user input. All right. Now, when I go into testing this, a couple of things that I would like to annotate. This favorite subject function doesn't take in a parameter or an argument, right? It's not taking in anything. It's providing an output, but it's not accepting inputs. So how could I possibly make sure that this function is working correctly? Right,
Make sure it's returning the right type.
Okay, so let's take a look at that. We go into assert and we call the type of what is my favorite subject. And then I run it, right? I say, hey, well, this should be a string. Now, if I run that in Pytest, we get a really weird error. So it tells me 2 tests have passed and 1 failed. And
Do you need to give it an input?
Yeah, it's asking for an input, but let's take a look at this test failure first. All right, it's telling me there was an assertion error because we were expecting a return. But we asked for an input and it looks Pytest captured don't read from input object. size -1, and then erases this. From Steadin, while output is captured, considered using S. Okay, so then you might think, all right, well, all I need to do is run pytest-s. And yes, it captures the output of what is your subject. And now in your terminal, it's asking you to actually type in what is your subject. Right? It's slowing down. Now it's executing the function in runtime and letting me, myself, type in, well, my favorite subject is math. And then it was able to execute it and return the string. But this doesn't give me much control over the test. Let's see what else I can do here.
Can you build an input into the test so it answers the input, not you?
Yeah, that's exactly what we're going to do. We're going to go ahead and tell the test to answer this question for us. And we're going to do that utilizing something called monkey patch. So monkey patch is essentially a way of saying, hey, I want to mock my specific information, or I want to mock some sort of behavior here. And I'm going to add an argument. Let me close this out. So all we have is the test suite here. I'm going to add an argument here saying monkey patch. This monkey patch word is built in to Pytest. So Pytest knows about monkey patch. When called as an attribute, or excuse me, when called upon within a test, it can provide access to setting values to different functionalities built into Python. So in this example, whenever we ask for an input, what we're actually doing is we are going into a built-in function that lives within Python. And this built-in function is labeled as input. And its behavior is, let me just say, while holding a set behavior to grab input or grab information from the user through the terminal. Now let's say I wanted to change that behavior. Well, what I can do is I can specify, hey, instead, utilizing monkey patch, I want to set a new attribute and or functionality to an existing attribute. And I do this utilizing the keyword set attribute. So let's go in there and access monkey patch dot set attribute. Now, once I have that set attribute, it's going to ask, well, what is it that we want to set? Well, I know that inside of the function built-ins, there is a function named input, or excuse me, inside of the built-ins, there is a function named input that I want to change the information to. So I would just pass it as a string. I would say, hey, in built-ins, there is an input method or an input function that I would like to switch. So I'm going to say first argument, specify the built-in function. I am going to overwrite. And as my second argument, I am going to provide the new behavior. So in my second argument, I am going to provide a behavior, which is a function. I don't care what the input is called, so I'm going to utilize an underscore, but I could still just call this X. I can call it user input because that's what we're mimicking. And what we'll be returning is the number 42. Or we can just say that what we're returning is math. Now let's go ahead and say that we want to print what is my favorite subject and run that there. Oh, let me run that with -v. Okay, let me try -s. There you go. Now, without me actually placing anything into the terminal, I am getting the return value of math. So what exactly is going on here? Well, let's take a look at both of our scripts side by side and break down this behavior. All right, so starting off with our testing file. From top to bottom, we say, hey, we're going to utilize monkey patch. And inside of monkey patch, what I'm going to annotate is that if at any point someone tries to utilize the input method, I am going to overwrite and return math. Everyone should see that little square in blue populate on my screen right now, right here. All right. So now that step got done. Let's continue into the next one. Now I say, hey, I want you to print what is my favorite subject. Well, then the function, what is my favorite subject, starts. And the very first step in what is my favorite subject is to ask for input. Well, its original behavior is to print to the terminal the content inside of it and to accept user input. But now, because I have changed the behavior of it, all it does is it automatically returns math. Now that it automatically returns math, that's what gets returned in my function. So the value of math gets executed here and here. All right. I see some hands up. Go ahead, Nick.
So it doesn't run the input command and then answer it. It just kind of pulls that little section of code out and replaces it with the string math. Is that correct? Or does it actually run input and answer it for you?
It doesn't actually run input and answer for me. What it does is we change the behavior of input. So all it does is accept this as its behavior.
So it's the equivalent when that runs of everything you have rectangled on the right-hand side of the screen to just changing it to the string math. Is that correct?
Yes.
Okay.
It was the same question I had.
All right. Any other questions regarding monkey patch?
I have one question. Is there a way to make this have like multiple test cases with Monkey Patch? Like
Yeah,
not just math, if you wanted a bunch of like you want integers and floats and whatever.
got it. So remember, input's always going to return a string, right? But we can have it return or ask a series of questions. So let's go ahead and go into an example like that. Let me erase all of my mess here. And let me just change this. See, this gives me a little bit more control of my test because now, as long as these two are matching, right, I can make something called maybe like an answer, and I make this a Python. I can refer to answer in both my assertion and my monkey patch. And that didn't work. Why didn't that work? Let's see. Oh, because I said type. There you go. That's what we do it. It gives me the ability to control what the input would be and what the expected output would become. So let's take it a step further and let's go into def or defining a function called build a person. And what build a person is going to do is it's going to create an object that's going to have a name. Say, what is your name? It's going to have a, oh man, what else could go into a person?
Age.
There you go, age, thank you. Input, what is your age? And let's say favorite color to keep it simple. And run \n, right? Well, now, if I go and execute my script, or excuse me, let me go ahead and actually run this function. So I get, what is your name? My name is Francisco. Oh, I never returned anything. So I'm just going to go ahead and kill this really quick. All right. And let me return this new person and actually print this onto my terminal. All right, so what is your name? My name is Francisco. What is your age? 27. What's your favorite color? And let's go with red. And it builds an actual dictionary with all those key value pairs with the actual values that I provided. Let's say that I wanted to mimic this behavior inside of a test suite to make sure that it works. Just gonna take this in as my answer. Let's pick this test. Test making a person. I'm gonna pass in monkey patch. I'm going to have an answer, which is going to look like this. And then I'm going to have responses, where the responses that I want will be Francisco, 27, and red. Those are the three responses that I want Monkey Patch to be able to build in to my iteration there. Now the question is, how do I do that? How do I ensure that multi-patch can iterate through something and actually change the independent values there? Well, I have responses. And if I make monkey patch and I say set attributes, I pass in the same information here. I go into built-ins, dot input, and I say that what I want to return is going to be a lambda function where the user input will always reference to my responses. Let's just assert true for now and see what happens when I run this information. There you go. Excuse me. So when I run Pytest, it says that this worked, that everything came back just fine, and that's because I'm not actually calling my function. So let me go through that portion there. So now we bring in build a person, and let's pass in print build a person. So build a person is working, and if I run pytest-s, let's see what that returns. Well, what it did is every time I asked for the input, it passed in the entire list of responses. So that's not necessarily doing the behavior that I wanted it to do. Maybe there's a different way to interact with this list so that every time it responds, it moves to the next value to return a new response. Well, what I'm gonna do is I'm gonna make iterable responses. And I do that by passing in the keyword iter of responses. Now let me go ahead and print iterable responses so we can see what that means. Well, iterable responses is a list iterator. It's not just a list, it's a list iterator. And what it does is by default, whenever I call this attribute of iterable responses, the value that it's going to return will be the very first value. So let's call that here. Let's say, hey, I want to go through this and go through my iterable responses. Now, when I go through my iterable responses, we can see that it's returning that object that is saved in memory space, but it's not something that's readable just yet. Well, how do excuse me? How do I actually make it move through the iteration process of hopping into Francisco, 27, and red? I do that by passing in the next keyword. We can say next. And now, when I execute my code, we'll see our actual answer of Francisco, age, and 27. Let's take a look at it here in this print statement as well. You'll see that if I try to pass it into this next or my input, my print function, it's actually throwing an error. Oh, no, it's not. There you go. So if I print in next, the only thing it returns is Francisco. If I come back down and I call next again, we'll see that first it starts at Francisco. The next time it iterates through it, it goes into 27. And if I were to call it a third and final time, it would return red. So in order to effectively build our dictionary, we need to have an iterable object that our function can use to iterate through whenever it's moving through the built-in methods. So finally, to close the loop, we would call our function of assert build a person is actually equal to our answer. And there we would get all 4 of our tests passing. All right, Nick, go ahead.
That next function, does that do something with the iterable where it keeps track of the number of times it's been called inside the iterable object?
It does, yes.
Okay.
So every time I call next, it moves it by an index. So it says, all right, well, now we're at Francisco. When I call next again, by default, it's going to move into 27. And when I call next again, it's going to move into red. Carlos?
So typically when you write this, would you do like you did there, set the responses as, Francisco 27 red, and then set another variable as iterable responses, and then pass in responses? Or could you just do iterable responses, and then assign it iter, and then your list instead of the actual variable? What's more common to do?
The latter. The only reason why I'm doing it this way is to make sure that everything's broken up into step by step and it's a little bit more digestible.
Gotcha, thank you.
Of course. Any other questions? All right, if there are no other questions, that's going to conclude our lecture for the day, everyone. Let me go ahead and stop our recording here.